Hey there, Pre-Calc students, Mr. Mistral, and we're going to take a look at nonlinear inequalities today. Got some information definitions up here above. Take a look at that are in your notes. But let's get into it. So we have certain steps that we're going to do. Solve each polynomial using these steps. Set one side of the inequality to 0. So in the first one, it's already done. Find the real zeros of the remaining polynomial graphically or algebraically. So we could graph this and find the zeros, or we could use algebra. We've practiced both before, and we can do the same thing today. So let's try to factor this. So let's try to factor this. Set up our two parentheses. What multiplies x squared? X and x. What multiplies 6? 6 and 1, 2 and 3. They have to add or subtract to 1. It's got to be 2 and 3. Signs have to be different. The bigger one has to be negative. Solve both of these. Get -2. Goofy thing. And 3. So we need to make a number line. And we need to place -2 and 3 on it. So since it's less than, we are going to have open circles. You can already address that issue. You need to have open circles. So now, where is it true? So let's check it. Okay. Plug in a number smaller than -2. Okay, so basically we have to check here, we got to check here, and we have to check here. So if you plug in, we'll just pick a number. How about -3? -3 squared minus -3 minus 6. Is that less than 0? So what's this? This is 9 plus 3 minus 6. What's that going to be? 6? Is 6 less than 0? No. So the answer is not over here. So then we try a number in the middle. Let's plug in 0. 0 is easier. 0, that makes that 0. That's 0. So -6 is less than 0. So it definitely is in this area. So we'll shade this in. There's definitely a solution there. Now plug in something over here. Again, it doesn't matter what number you pick, it just has to be clearly over there. So let's try plugging in 4. 4 squared minus 4 minus 6. And you probably already see that it's 16 minus 10, so 6 is less than 0. That's not true. So that's not over here. So here's our answer. This is where this inequality is true. It happens from -2 to 3. So now we're going to try letter B. First step, you need to bring the -48 over. So you add 48 to both sides. Now we could solve this factor by grouping, but we're going to use a calculator. So I go to my calculator, I type it in, 2x cubed minus 3x squared minus 32x, and then plus 48 since you brought it over. And then you're going to graph it. So it looks like it crosses here, here, and here. It looks like we have 3 zeros, which we should since it's x cubed. So let's verify what those zeros are. So I go to the left of, we're going to find the first point here. You got to go way up. If you look at these numbers, it tells you where you're at. If you're not sure. So right there is the cursor. Go to the left, hit enter. Go to the right, hit enter, and then guess near the point. So -4 is one of our zeros. We should record that. Second calc 0, and then we got to go to the left of this other point. Right there it is. Hit enter. Then go to the right, hit enter, and then guess near the point. Again, you don't have to be right on it. So positive 1.5 or 3/2, whichever one you want to call it. And then last but not least, we need to find our other zero. So we go to the left of the point, hit enter, and then we go to the right of the point, hit enter, and then we guess near the point, and it's 4. So we have 3 zeros, so let's head back to our zeros, x equals -4, 3 halves, and 4. Okay, so let's do our number line test. Here's -4, 0 somewhere right there. Here's 3 halves, and then over here's 4. So that's what we're testing. We're not really testing 0, but I just want to put that on there. So what happens when you plug in different numbers? Okay, we just need to do our test. So plug in a bigger number like 5. You can use your calculator. Plug in 5, plug in 5, plug in 5. Is it a true statement? I would usually go here and plug it in. If you plug in 5, you end up getting a negative. So another way to check for it, we need to make this positive. So here it's a negative. You plug in 0, 0, 0, 0, 48. Is 48 bigger than 0? Yes. This interval was positive. And then from 3 halves to 4, again, plug in, plug in 2. That'd be a good number to plug in. Plug in 2, plug in 2, plug in 2. Again, using your calculator, you're going to find that this is a negative. It's a negative. And then plug in a bigger number, plug in like 5. So plug in 5, plug in 5, plug in 5. See what you get. When you do that, it is also positive. So what are we trying to make it positive or negative? What is our solution? These all can't be answers. So we are looking for a bigger than 0. So our answer is from here to here. And then from here forever this way. So those are our 2 solutions. Okay. Writing these in interval notation, because that could be a question that you're asked to do. So the first interval was -infinity to -4. And it's a negative. And then our next interval was -4 to 3 halves. And it was a positive. And then we go from 3 halves to 4, and that's a negative. And then you go from 4 to infinity, and that was a positive. So interval notation, these 2 would be our answers. Just another way to write it. We can write it on a number line, or we can do it in interval notation. Free response-wise, you can put either. If it were multiple choice, you'd need to be able to match. It probably would be written in interval notation if we were doing it as a multiple choice question. So, all right, let's take a look at letter C. Take a look at letter C. We do have to subtract the 6 on both sides and bring it over. So we're going to have 4x squared minus 5x minus 6. And since it's a quadratic, let's definitely factor this. So let's write our 2 parentheses. So what multiplies to 4x squared? Is it 4 and 1, or is it 2 and 2? Well, we need to get 5, and then we also have the 6. So we're going to try something, and if it's wrong, we'll try something else. So let's just go 4x and 1x and see what happens. Okay? And then we got our 6. So is it 2 and 3 or 6 and 1? Or flipped. If I put a 6 here and a 1 here, I don't think I can make 5 out of that. Or if I put a 6 here and a 1 there, that's not going to work. So if I try 2 and 3, what if I put a 3 here and a 2 here? This is 3. This is 8. Can I make 5 out of 3 and 8? Yes. So my signs are different. My bigger one needs to be negative. So I need to make the 8 negative and the 3 positive. So here's how I factored it. Here's the correct factor. So my 2 x values are -3/4 and then 2. So let's put it on a number line. I know not a very straight number line, but we'll deal. So -3/4, and then there's 2. So we need to plug in a number over here. So let's just plug in -2. So if you plug in -2, that's going to be 4, so that's 16. You minus the 6, that's 10. If you plug in -2, it works. Okay? So this is true, so we definitely have, first we have open circles. We do have to put those. We definitely have an answer coming this way. Then try a number in the middle. If you plug in 0, 0, 0, is -6 bigger than 0? No, so you're not in here. And then plug in a number bigger than 2. Plug in 3. Plug in 3. That's 9. 36. Plug in 3. That's -15. It's definitely going to be big enough to be positive. Shade that way. So our solutions are in the tails here. Okay, so now what about rational inequalities? What about those? So it's really the same type of thing. We have to find our intervals. We have to set it equal to 0. So our first step, set this thing equal to 0. So 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And now we have to do a little bit of algebra. We do have to get a common denominator, least common denominator, which is usually just the bottom here of this. So we need to add these two, or subtract, in this case, these two fractions. So my LCD is x minus 5. We're still less than or equal to 0. This first fraction, you don't have to do anything to it. But since you multiply the bottom by x minus 5, you have to multiply the top times x minus 5. So what I'm going to do here, you're going to subtract, so you can leave the negative here. So it's 3x minus 15. You have to take 3 times all of that, and you get this. So now we can put the two fractions together. So we're going to have x minus 5 on the bottom. Still less than or equal to 0. So be careful here. You got to do 2x minus 3x, which is negative x. Then you got to do -7 minus -15, which is plus 8. So now that you've got this, you have to be aware of the top and the bottom. So really what you end up doing, you take the top, set it equal to 0. You take the bottom, set it equal to 0. Basically, the top will make it 0. The bottom makes it undefined, so it's a critical point that we need to be aware of. So when I solve these, you get x equals 8. If you add x to the other side, and then if you add 5, you get these two. So we can make our number line again. Put 5 and 8 on our number line. And then we can do our testing to see where we're positive, where we're negative. So check those. So do your test. If you plug in 0, because that's to the left of 5, 0 makes it 8 over -5, which is less than 0. So our solution is going to be this way. Open circles in both places. You can't have 5 or 8 be an answer. If you plug in, let's just say 6, plug in 6, you get 1 on the bottom. Plug in 6, you get -6 plus 8, which is positive 2. That is not less than 0, so we're not in here. And then if you plug in, let's just say 10, plug in 10, you get a -2 on the top over 5. That is negative, so your solution is also this way. Okay? Go ahead and pause the video and check the problem below. When I say pause the video, pause, do the problem yourself, and then check the answer. Okay, hopefully you had a little bit of time to do that. If you didn't pause it, then you obviously could see the answer right away. But here you go. You've got to bring the 4 over, get an LCD, set the top and bottom equal to 0, make your number line or your intervals, and then see where it's positive and negative.